symbols below with the three types of atoms used in Model 1.
So I see that R is
Wait, yes, okay.
SQ squared or underscore would be 2. So it's like a square by process of elimination, right?
1 square. So do we agree that SQ is 1 square?
I agree.
So if we look at TSQ squared R, that means 2 squares and 1 R, which is a circle, which means that the last thing remaining is a triangle. Do we agree that T is a triangle?
Yep.
Do you agree? I agree.
Right. Group agrees as.
I like how you got Rainey's.
Alright, so that's all we're in agreement on that.
Question 3. In Model 1, there are 3 objects labeled as molecules. How many atoms are in a molecule of RSQ?
I believe that there are 2.
I agree with you.
Oh yeah, we've got the circle and the square, right? Okay. How many atoms are in a molecule of SQ? 2.
I agree.
2.
Oh yeah, we're looking at atoms.
Great. Question 4. Refer to Model 1. How many atoms are in a molecule of TSQ2R?
It's like 4 to me.
I agree.
I agree.
I should be asking, because when I hear agreement, I'm just writing it down, but are you guys okay with that?
Rainey, do you agree with 4?
Yes. Yes. Yes.
That means atom types, right?
Parts A and B. Would you please send your spokesperson to write the answer?
Okay.
And it's up here, you can see it.
Okay, perfect. All right. So how many SQ atoms are in a molecule TSQ2R?
2.
It's like 2 to me.
I agree.
Yeah.
Kate, do you agree?
Oh, yeah.
Okay, so now that we've finished for our spokesperson, is going to record that up on the board, please.
I wonder if you could read the next
How
one.
many atoms are in a molecule of
Oh, okay, good.
I like how you noticed your mistake.
Yeah, all right. So number 5, can a molecule be made of only 1 atom? Support your answer with evidence from Model 1.
SQ atoms are a model of SQ.
We have a question. Can we ask?
Looks to me like the first one, R, is, wait,
It's made up of only 1 type.
height, right, okay, good point.
But I don't know if it's only
Doesn't
1
appear.
atom.
Well, it does have an arrow pointing one atom to this circle.
1 atom.
That would make me think that it's 1 atom.
I hear what you're saying, but I think they're asking about a molecule. Oh, only 1 atom, but a molecule.
Yeah, so the bounded rectangle, from the way this diagram looks, the bounded rectangle is a molecule, right? And there are no, to me, illustrations of a molecule that contain only 1 atom.
Got it.
I would agree with that reading of it.
Okay.
Yep.
Okay.
The answer to number 5 is no.
What's our evidence?
There are no examples of molecules with 1 atom.
They all have at least, yeah.
Yeah.
Are you comfortable with that language? There are no examples.
Of a molecule
With
with 1
less
atom.
than, with 1 atom.
Yeah.
Okay. Number 6. According to Model 1, when several atoms are grouped into a molecule, what holds them together?
I noticed that in this one, bottom left and the bottom right, it says chemical bond.
I agree with that.
Good eyeballs.
Thank you. I like how you encouraged me.
Now, although this makes me question our previous assumption that this bounded box represents a molecule, right? This is a bounded box. It is not a molecule. So, does that mean this in fact can be a molecule?
As well as an atom.
Oh, well, the only ones that we have labeled as molecules, though, these are the ones that are labeled as molecules, these ones in the ovals.
Can you expand on what you said? What do you mean by a bounded box?
So this box, the rectangular thing, initially I believed that the box itself represents a molecule. And that the objects within it were the atoms of the molecule. And now I'm seeing a counterexample. I'm seeing a molecule with, well, that's right, atoms and others. So this makes me reconsider that this in fact is not a molecule.
I believe that we wrote down that there were not examples of a molecule with one atom. So I think that was what we said.
I agree, I think that's still correct, because still the three things that we see labeled as molecules, none of them have just one atom.
So you think this circle that surrounds, right? Because this is, you're saying the absence of a label is enough to determine that it's not a molecule. If it has a label, it's a molecule. If it's not a label.
I believe that if this one was a molecule, it would have something saying this is a molecule, because I noticed that these are labeled.
Are we okay to stick with that for now and move along?
Yeah, let's see if we get any other.
Okay, sounds good.
I like how you double check our thinking.
Another thing you're welcome to do, if you want to send us by to one or another of those, and ask them what their understanding is, you can send us by to Thank you.
So just to clarify, for number 6, I'm writing down that chemical bonds are what holds them together. That we're comfortable with that.
I think we are, I think we all agree.
This is a little a processy thing. How do you guys feel about being spies? You're just wanting to tighten our own little cluster right now?
Science, we should be sharing stuff openly, right?
I mean, I didn't see anybody jump up to be a spy.
Unless they work for Monsanto.
I hear what you're saying, but I think by spy she just means
No. I know. I just as the quality controller, I wanted to check in about the spy
Oh, good,
issue.
good, yeah.
Yeah.
I like how you checked in.
Thank you for encouraging it. Very good. I'm glad you did that.
All right.
And of course, we'll reduce our human power by 1, but we'll
Oh, yeah.
have a spy, so that's also a positive.
All right, let's move along. Number 7, fill in the blanks to complete the definition of a molecule. A molecule is a group of 2 or more blank held together by a blank.
I believe because of what we said earlier about, well, I noticed that this circle is one atom and there's one in this molecule, so I believe that's the atom. And in the previous question, we said that they're held together by chemical bonds.
Yep.
I agree.
2 or more atoms held together by a chemical bond.
Right, for T for R,
Okay.
so there's 3 that make it up, but there's 4.
So Rainey, I know I might step on your toes.
Yeah, me too. All right. As a group, discuss the following questions and record your answers. Be prepared to support your answer using the diagrams in Model 1. A, can a particle be a single atom?
I believe it can. I notice in the square that's labeled R, it says that there's 8 particles, meaning an atom is a particle.
Agree?
I agree.
Can a particle be a molecule?
Ooh.
I also notice in RSQ it says 5 particles, and those are molecules, so 1, 2, 3, 4, 5.
Or should I get up there?
I agree.
We want to say yes for that one as well?
Yes, we agree?
Yep.
These are, and we need at least 4.
9. How many particles are in the drawing representing TSQ2R?
Like 5.
I agree. Rainey?
Yeah.
Thank you, Lindsay. Thank you, sir. And you are taped.
All right, managers, do you need 0, 1, or 2 minutes to finish all the way to the bottom of the sheet? So managers, 0, 1, or 2 minutes to finish. 2, 2, 2, none. Okay, so we'll take 2. So we'll change our time point to 5:25, and we'll report out. Notice, while we have your attention, check to be sure your answers to 4A and 4B match here. I'm real happy with this answer. All right? So 5:25, these will all be filled in, and you will then check to be sure we're all in agreement.
Wait, so we're not.
We're not all in.
We're done?
All right, let's try and get through this. So 10 is compare the codes listed at the top of each drawing in Model 1 with the shape in that box. What do the small numbers, subscripts, in the codes represent?
I noticed that in SQ2, there are 2 squares, so I believe that the subscript 2 represents how many atoms are in each molecule.
That totally makes sense, actually, now that I see it.
So it represents the amount of atoms in the molecule. Do we agree?
Yeah. It's interesting.
The number of atoms.
The smallest number.
Would we, should we clarify that to, it's the number of like specific atoms, right? Because it's the number of the SQ
Right.
atoms, right?
Maybe you could give an example. So say, for example, an SQ2 is 2
Sure.
squares
Smallest
Or a number
number
of atoms of that type or something.
represents
of that type. I
number
agree with
of
that.
atoms.
Good. Now, group 1, I recognize you have not drawn number 12 yet. I'm going to have teams 2, 3, and 4 come up and explain their answers, and you can complete yours from their explanation. All right? So team 2. T3, what did you draw and why did you draw that? Come on up and explain to group 1. Okay. Who's your spokesperson is? Come on up, yeah. Be a star.
Okay. So we found the T meant triangle, so the subscript meant the amount of that atom, so we put 3 triangles together.
Any questions? I have one. Why not just 3 triangles floating around by themselves?
Because a molecule has connected by chemical bonds, and so we had to have them bonded, otherwise they just be loose atoms.
Okay, so what, for someone else, what is the way in this model that a chemical bond is depicted? How do they show that there's a chemical bond present? Yes,
The atoms are touching.
touching. So just touching. Is there anything special about the way you organize those triangles?
So there's no gaps in between.
Yeah, so you could draw them a number of different ways. They need to be 3 triangles, and they all have to be somehow touching so they make one unit, but there's nothing special about the way. We have no other information about the shape that they would be. We don't really know that from the information we have, so thank you very much. Okay, group 3, your spokesperson.
So we,
As you wait for a moment and face your peers. Thank you.
so as with group 2, we found that SQ meant square and T meant triangle, and the 2 as a subscript meant that there were 2 triangles, so I drew 1 square and 2 triangles.
Okay, and would you make one more statement about that to make us feel comfortable if we didn't draw exactly that shape? I know I'm putting you on the spot.